Here's our second example. If this is the horizontal, that's where we start out looking. Angle 3 goes down, so it's an angle of depression. Angle 4, this is our horizontal, and angle 4 is above that, so that is an angle of elevation. Number 5 uses that same horizontal, and they're looking down, so that is an angle of depression. And for number 6, here's our horizontal. That angle is above, it looks up, so that is an angle of elevation. The next examples, we're going to have to draw some pictures. Seattle Space Needle casts a shadow that is 62 meters. So here's the Space Needle, and I'm going to draw the shadow right here, 62 meters. Angle of elevation from the tip of the shadow to the top of the Space Needle is 70. Alright, I'm going to change this picture because it wasn't very accurate. So here's our shadow, 62 meters. And the question is, based on that information, how tall is the Space Needle? Well, this would be a right angle right here, so we can use SOHCAHTOA. That is the opposite side, and this is the adjacent side. So we will have the tangent of 70 equals x over 62. We can grab our calculator. 62 times the tangent of 70 is 170.3 meters. Suppose a plane is flying at an altitude of 3,500 feet. So this is my plane high up in the air. The angle of elevation, so this is the ground, this is the angle of elevation, is 29 degrees. And the question is, what is the horizontal, it's an important word there, horizontal distance between the plane and the airport? Well, the plane is right here, the airport is right here, and you are asked to find that horizontal distance. So that's the opposite side. This is the adjacent side. So we have the tangent of 29 equals 3,500 over x. To solve that, you switch these two, and that becomes x equals 3,500 over the tangent of 29. Grabbing my calculator, 3,500 divided by the tangent of 29 is 6,314, and this was in feet. Top of the next page, an ice climber stands at the edge of a crevasse, which is 115 feet wide. So basically we have these two big blocks of ice here, and we have this guy standing up here. It is 115 feet wide, and the angle of depression, so looking down, is 52. Over here, that will form a right angle, and you are asked how deep that is. Well, if this is our angle of depression, that is the opposite side, and the 115 is the adjacent side. So you have the tangent of 52 equals x over 115. Grabbing your calculator, 115 times the tangent of 52, that is approximately 100 147 feet deep. The next example says, suppose a forest ranger sees a fire. The angle of depression to the fire is 3 degrees. So that means right here, that's 3 degrees. You are asked to find the horizontal distance to the fire, rounding to the nearest foot. Well, if this angle right here is 3 degrees, that means this angle right here will also be 3 degrees. So I'm going to say the tangent of 3 is 90 over x. Tangent is opposite over adjacent. And if you end up with that, you have x equals 90 divided by the tangent of 3. So 90 divided by the tangent of 3, and that distance is 1,717, and this one is also measured in feet. So that's how far it is to the fire. A pilot is flying at an altitude of 12,000 feet. So here's this plane, 12,000 feet. Angle of depression is 14 degrees. So from the horizontal going down, that is 14 degrees. That means this angle down here will also be 14 degrees. And you are trying to figure out the horizontal distance. We know the opposite side. We're trying to find the adjacent side. So we will have the tangent of 14 equals 12,000 over x. So 12,000 divided by the tangent of 14. I guess I should rewrite this. You switch those around. And some of you might be getting to the point where you don't need to do that.
Victor Vandertorn, please come to the office. Victor Vandertorn, thank you.
Sorry about that announcement. When you divide that, you get 171,607, roughly 608 feet. Boy, that seems like a lot. So there we go. Next one. Pilot is flying at an altitude of 22,000 feet, and he is 145,000 feet from the runway. And we want to find what the angle of depression would be. So we're trying to find this angle right here. This is the opposite side, and this is the adjacent side. So the inverse tangent of our angle, let's call it A, is 22,000 over 145,000. You can just enter it into your calculator like that. Inverse tangent, 22,000 over 145,000. Inverse tangent, 22,000, 145,000, and your angle here ends up being 8.6, which means your angle of depression would also be 8.6. And I guess I would round that and say it is about 9 degrees. An observer at a lighthouse is 68 feet above the water. So here's our lighthouse, 68 feet above the water. And he sights 2 boats. One, the angle of depression is 48 degrees. So this one right here the angle of depression is 48 degrees. Now the second one, 68 feet tall, our angle of depression, so from the horizontal, our angle of depression is 22 degrees. And the question is, what is the distance between the two boats? What we're going to have to do is figure out the distance from this first boat, the distance from the second boat, and then subtract those. So let me relabel this. Lighthouse is 68 feet tall. If the angle of depression is 48 degrees, then this angle is also 48 degrees. So we will have the tangent of 48 equals opposite over adjacent, 68 over x. To solve that, you swap those two. So we have 68 divided by the tangent of 48. So that boat is roughly 61 feet away. Now our second boat, 68 feet high, this angle is 22 degrees, then this angle is also 22 degrees. So we will have the tangent of 22 equals 68 over y. To solve that, you switch those two and divide. 68 divided by tangent of 22 is roughly 168 feet. And then to find out how far apart they are, 168 divided by 61 is 107 feet. We have a couple more examples on the back page. One just like that, a plain one, like the one we just did. Pilot flying from an altitude of 12,000 feet sights two different airports. So 12,000 feet. Angle of depression to the first airport, angle of depression is from the horizontal, is 78 degrees, which means this angle will also be 78 degrees. And I'm going to draw a second picture, 12,000. The angle of depression here is 19 degrees and 19 degrees. And we need to find the two distances and then subtract them. So if we know this angle, opposite over adjacent, we have the tangent of 78 equals 12,000 over x. Flip those two things around and you will have 12,000 divided by tangent of 78. So this first airport is 2,550 feet away. The second airport, we have the tangent of 19 equals opposite over adjacent. We're going to switch those two things and divide. 12,000 divided by the tangent of 19 is 34,000. I'm going to round it to 851 feet. To figure out the distance between the two airports then, 34,851, subtract 2,550, and there is 32,301 feet between them. And the last thing we have is the area of these triangles, and this is really kind of a cool formula. The formula for the area of a triangle is 1/2 AB sine of C. So to find the area here, we're going to do 1/2 4 times 7 times the sine of 75. And we can only use this if we know two sides and the angle between them. So punching that in, 0.5 times 4 times 7 times the sine of 75, it is 13.5. And the hardest part of this is remembering the formula. And sometimes we write 1/2 AB sine of theta. They use Greek letters for angles a lot. Example B, we will have 1/2 7 times 11 times the sine of 110. So 0.5 times 7 times 11 times the sine of 110 is 36. And I probably should label these square meters, and that one would be square miles. Letter C, 1/2 AB sine of theta, 1/2 10 times 15 times the sine of 60. So we have 0.5 times 10 times 15 times the sine of 60. That is right about 65 square inches. And the last one, 1/2 28 times 42 times the sine of 30. 0.5 times 28 times 42 times the sine of 30. And that is 294 centimeters squared.